Episode 10. We've made the model run, sized it, called it, controlled it. Today we ground it in our own knowledge base. This is RAG. Here's the problem. The model knows what it was trained on. General knowledge, public text. It does not know your documentation, your policies, your specific data. Ask it about those, and it has to guess or hallucinate. RAG fixes this. Before asking the model, you retrieve relevant chunks from your own data. You feed those chunks alongside the question. The model answers from your context, not from training memory. We'll see the full RAG pipeline. Embed, store, retrieve, generate. We'll build the intuition for cosine similarity, the math behind retrieval, then a real run on a small corpus with the test that proves RAG is actually doing its job. First, the pipeline and the math. Then we go to the terminal and watch RAG retrieve from a real corpus, ground a real answer, and correctly refuse what it doesn't know. Recap: RAG grounds the model in your data by retrieving relevant context before generating. Next, the pipeline, the math, and a real local run. RAG is 5 simple steps and 1 math idea. Take them one at a time, and the whole thing becomes obvious. 5 steps. Embed turns text into vectors. Store keeps them. Retrieve finds the most relevant ones for a question. Augment puts those chunks into the prompt. Generate gets the grounded answer from the model. That's RAG. An embedding is the embed steps output, a vector. Think of it as turning text into a point in space. Real embeddings have hundreds of dimensions. You can't picture that, so picture 2. Same idea applies. Here's the key insight. The embedding model is trained so that texts with similar meaning point in similar directions. Texts about processes and threads cluster together. A question about France points somewhere completely different. Meaning becomes geometry. Cosine similarity is just the angle between 2 of these arrows as a number. Pointing the same way scores near 1. Perpendicular scores 0. Opposite scores -1. So how similar becomes how aligned their directions are. Retrieval becomes simple. Embed the question, compute the cosine against every chunk, sort, take the top few. The closest arrows are the most semantically similar chunks. That's all retrieval is: similarity, ranked. 5 steps, 1 geometric idea. That's the whole RAG pipeline. Now we go to the terminal and run it on a real corpus and see if it actually grounds the model the way the theory says it should. Recap: RAG is embed, store, retrieve, augment, generate, and cosine similarity is just the angle between embedding arrows, scoring how aligned their meanings are. Here's the whole RAG pipeline: 1 Python file, about 50 lines, no framework. Let me walk it top to bottom so you see every step. Imports config. At the top, requests for HTTP, NumPy for the math, and 3 constants, where ollama lives, the embedding model nomic-embed-text, and our generation model, Gemma for E to B. Section 1, the corpus. 15 plain text chunks, generic tech interview content, processes and threads, ACID, idempotency, TCP, caching. This is our knowledge base. Real RAG corpora are huge. Ours is small so you can see the mechanics. Section 2, embed. 1 function. Post a string to ollama's embeddings endpoint. Get back a vector of 768 numbers. We loop the function over all 15 chunks and store the vectors. Section 3, retrieval cosine. Section 3, retrieval. The cosine sim function, dot product over the product of magnitudes. That's the angle between 2 arrows in 768-dimensional space as a number from -1 to 1. The retrieve function embeds the query, scores it against every stored vector, sorts, and returns the top k. Section 4, augment and generate. Take the top chunks, stuff them into a prompt with explicit instructions, answer using only this context, send to Gemma's chat endpoint. That's RAG. Section 5, try it. Section 5, try it. 1 query, retrieve, print the scores, print the grounded answer. Now we run it. I'm not installing Python on my host. A disposable Docker container, network host so it can talk to ollama on 11435. Mount the current directory, install deps, run the script, and the container disappears. Same Docker discipline as the rest of the series. First query: what's the difference between a process and a thread? Watch, 15 chunks embedded, 768 dimensions each. The retrieval finds the process thread chunk at 0.903. That's a near-perfect direction match. The next two hits are way below at 0.59 and 0.58. Big gap. And Gemma's answer is grounded directly in that top chunk. RAG working. Now the real test. Query: what is the capital of France? Nothing in our corpus is about France. Watch the retrieved chunks: REST API, ACID, TCP, all low scores around 0.5, all irrelevant. And Gemma's answer? The context does not contain the answer. It refused. Gemma absolutely knows the capital of France from its training, but the prompt said use only the context, and the context had nothing, so it refused instead of hallucinating. This is what RAG actually does. It grounds the model in your data and refuses outside it. The trust property. One more. Query: why is my API retry safe to repeat? Watch, the idempotency chunk comes back top at 0.685, even though the query never used the word idempotency. Semantic search for vocabulary gap. Gemma's grounded answer? One clean sentence, sourced from the corpus. Now look at Gemma without RAG. Same question. 3 pages of training data essay, idempotency keys, HTTP method tables, the works. More content, but it's ungrounded. RAG isn't smarter. It's grounded and controllable. That's the real trade-off. That's RAG. 5 steps, 1 geometric idea, and 1 honest insight. It doesn't make the model smarter, it makes it grounded. We covered it. The 5-step pipeline, cosine as the angle between meaning vectors. The refusal test, RAG correctly saying I don't know when the corpus didn't know. And the real trade-off, grounded, not smarter. Your quick reference, embed with nomic-embed-text via ollama. Store as a Python list of text and vector pairs. Retrieve with cosine similarity. Take the top few. Augment the prompt. Generate with Gemma. About 50 lines, no framework. What this minimal version skips and we'll cover later. Persistent vector stores. How to chunk long documents. And making retrieval actually work well when the corpus gets messy. Future episodes. Embed, cosine, ground, generate. That's episode 10. Real RAG on real hardware. About 50 lines of Python talking to a Gemma 4 model running on the same machine. Subscribe to follow the series. We keep building on this foundation, episode by episode. Thanks for watching.